Welcome everybody to Unit 6, Lesson 6, the final lesson of the year, scientific notation. So we're going to be learning about students will be able to write large numbers. So we're talking about very large numbers. Let's say I had the number like 1,873,000. And I wanted to write that as a much smaller number. Well, I can count all the base 10 all the way up to creating the ones value. So I can change this number to 1.873, and I want the equivalent number times 10 to the 6. That means 10 decimal places, or 6 decimal places. I have moved the decimal point from that original point here. I could do that with very small numbers too, in the opposite direction. So let's say I had the number 0.000063. Well, then I can move it 1, 2, 3, 4. We're talking about even smaller numbers than that. 3, 4, 5 places. So I can change that to 6.3 times 10. Now I made a small number larger, so I have to do the opposite. So instead of it being 1, 2, 3, 4, 5 positive, I moved it in the other direction. 5 decimal places the other direction. 5 decimal places. And we can do this because we're using a base 10 system. And when I think of a base 10 system, I think of numbers like, I'll start with the number 10, and then 100, 1,000, 10,000. This is how so that's 10, 100, 1,000, 10, 100,000, 10,000, and you keep going this way to the millions and the billions. And you learn this as a kid in elementary school, that this is the base 10 system. Now after you go, you can notice that the decimal point is moving 1. Here's a decimal point, here's a decimal point. You've lost a 0. You've lost a 0, you lost a 0. So you don't go to 0, you go to 1 here. That's 1. And then you go to 0.1. So we're moving this decimal point 0.001, 0.0001. So this is what we call our base 10 system. So we have 1, and we have tenths, and then we have hundredths. Okay, and then we have thousandths. I have to write it up here. And then we have 10,000ths. So we are learning that there's multiple ways to represent this. Okay, so another way to write a tenth is 1 over 10, right? And this is 1 over 100, and this is 1 over 1,000, and this is 1 over 10,000. Okay, and this is 1 and 10, 10 times 1. Okay, so let's look at it with exponents. What about if I wrote it exponents? Well, let's think about what these are. Let's think. This is 10 times. Let's go with 10 times 10 times 10. Okay, 10 times 10 is 100. Times 10 is 1,000. Times 10 is 10,000, or 10 to the 4th. Okay, well, let's see if there's a pattern here. 10 times 10 times 10. Oh, this is 10 cubed. 10 times 10 is 10 squared. So here's our exponents here. Looking really good. that I'm a little bit zoomed out here. Let me zoom back just a little bit. There we go. You can see that just a little bit better. Exponents 10 to the fourth, 10 cubed, 10 squared. We're seeing a pattern. 10 to the 1, 10 to the 0, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4. So we have, this is just 10. This is, let's skip this in terms of this, and we'll go here. We also have this 1 over 10, 1 over 100, 1 over, okay, so we have that. And we can see as our rule evolves. Remember, this is 1 over 10 cubed, 1 over 10 to the fourth, 1 over 10 squared, and 1 over 10 to the 1. So what do we see here? We see right here, this whole thing is our exponent property for negative exponents. What did that property say? It said, oh, well, if we had 10 to the negative 4, we could rewrite that as 1 over 10 to the fourth. If we think about it in terms of what we had the other day, here we had our exponent rules, and we did 1 over 10 to the negative n equals b to the n. So if we're looking at it here, this would be, this case, 1 over 10 to the negative 4 equals 10 to the positive 4. So that's our base 10 system here. So we're going to be using that idea to write large numbers in scientific notation or small numbers in scientific notation and expand numbers in scientific notation into standard notation. So if you have something in scientific notation, you need to know how to get it out of scientific notation back into standard sometimes. Students will also be able to perform addition, subtraction, multiplication, and division with numbers in scientific notation. Okay, so, and why is it useful? Okay, two reasons. One, it allows us to represent really large, extremely large and small numbers, and we can apply those exponent rules within scientific notation, and we can do calculations that way. So, two really big essential questions. Remember, these are going to be big points at the end when we take our unit CSA here. And we talked about scientific notation. One of the biggest things here is the lead number has to be in the ones place. That means it's between 1 and 10. That's the first number is in the ones place. And you see that up here at the top example. We moved it so that this number is between 1.8 is between 1 and 10. So the lead number is between 1 and 10. This is a fancy way of saying that the first number is between 1 and 10. So you can see this huge number here. The decimal point was here. 1, 2, 3, 4, 5, 6, 7, 8 spots, and that's why it's indicated that you've moved it 8 spots. Notice that this number here, this is between what numbers? 1 and 10. Okay? If you're making large numbers small, that exponent's going to be positive. If you make small numbers large, that exponent's going to be negative, meaning you move the decimal point the other direction. If the number is greater than or equal to 1, the power of 10 is positive. If the number is between 0 and 1, the power of 10 is negative. So that just means really small numbers. When they say between 0 and 1, let's say it's 0.000000342. Okay, so if I move that to 3.42 times 10, 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. Okay, so this number, if the number is very small, your power of 10 is negative. Like you see here, right here. So, and then they say if the number is greater than 1. What do they mean here? Greater than or equal to 1. They mean it's a big old number. Let's say I had 3, 4, 6, 8, 7, 0, 0, 0, 0, 0, 0, 0. That's 346 billion. So if I rewrote that, it'd be 3.4687 times 10 to the 3, 6, 9, 10, 11. So the original number, the first number is really big. So the power of 10 is positive, which you can see here. So big numbers have positive, tiny numbers, negative. That's the key. Large numbers, positive exponent. Small numbers, negative exponent. So we can expand these. Or what I should say is write it in standard notation. Here we have 7, 4, 2, 1, 2. I need to get, it was there, 1, 2, 3, 4, 5. Okay, what are you going to get for B? It's negative, so you're going to move it the other direction. What's the final answer going to be? Once I move it, I have a 1, a 6. I need to put a 0 and a 0 because I moved it 2 to the left. What am I going to get for C? This is positive. I'm going to, remember I moved the decimal point right, making a larger number here. So what are you going to get for C? You're going to get 371.4. You want to be able to write large numbers in standard notation, in scientific notation. Write in scientific notation. So here we're going to count. The decimal point's there. 1, 2, 3, 4, 5, 6, 7. What is it going to look like? 1.414 times 10 to the 7th. Here, a very small number. We're going to move it 1, 2, 3. What do we get? 8.76 times 10 to the negative 3. We only have to move it one time here. 1.14 times 10. Now it was small, remember? So we moved it the other way. So small numbers are represented with what? Negative exponents. Small number, negative. Large number, positive. Okay. So let's take a look. If we were to compare countries or currencies, here we have a problem. Some of the top U.S. cities visited by overseas travelers are shown on the table. Order the cities according to the number of visitors from greatest to least. Okay, well, these two have the biggest, this is times, if I was to write this out, it would be 1.3 times 100,000, and this would be the same thing, 2.2 times 100,000. And here we would have, this is only times 5, so it's 7.21 times only 10,000. So this is much smaller, and this is 9.01 times 10,000, only times 10,000. These are 10 times larger, so we want to order from least to greatest, okay? So the least would be here, this is the least. And then the most would be, or the greatest would be here. And then this is the second least. And the second most. So you're starting to, you want to develop a little bit of that reasoning. We can also multiply or divide with scientific notation. So here we have a situation where we're going to evaluate. Okay, so what we can do is we can apply the rules of exponent rules here. And how we're going to do that is if you have the same bases, you can add the exponents. So we're going to use a property, the commutative and associative properties of multiplication here. We have a number in scientific notation times another number. Okay, well, what we can do then is we have 7.2 times 10 to the third and 1.6 times 10 to the fourth. Let's put these two numbers and multiply them together, and then we'll put the base 10 numbers together to multiply. We can, if we do that, if you look at this part right here, we know that if the bases are the same, we add the exponents together, if you see that. So we get 10 to the 7th, and then all we have to do is do the multiplication of the lead numbers. We have to use a calculator for that. So we have 7.2 times 1.6, and that's 11.52. Okay, now notice that we are not, it's this number here, right here, it's not between 1 and 10. So it's not in scientific notation. I need to move the decimal point one more, move it one more, and now it's in scientific notation. And we're good to go. And so since I moved the decimal point 1, I need to make this number 1 bigger because I made this smaller by 10, so I have to make that one larger by 10. So that's why the 7 goes to an 8. So here, let's do 8.4 times 2.5, and then we'll group the 10 squared times 10 to the 6th together. So we'll do this with a calculator. I'm going to get my calculator. I'm going to do 8.4 times 2.5, and I get 21. Okay, that's good. 21. Now the property here, if the bases are the same, I'm going to add the exponents. So I get 21 times 10 to the 8th. But I'm not in scientific notation yet. This number has to be between 1 and 10. So I need to move it to 2.1. I made it smaller by 10. What am I going to do to this exponent? I'm going to make it larger because I have to compensate. Okay, we'll do one more. 2.63, we're going to associate this one with this 1.2, and then we'll group the 10 to the 4th times the 10 to the negative 3 together since they're the same bases. This might work out really good here because this number 2.63 times 1.2 will end up being 3.1. This is 3.156. So is that between 1 and 10? Okay. Here we have 10 to the 4th plus. So where bases are the same, we add them together. We get 3.156 times 10 to the 1. And we're done. Why are we done? Because this number is already between, the lead number is between 1 and 10. So we're going to pause there and kind of split this lesson into two. We'll finish with another lesson on adding and subtracting with scientific notation to finish it up. We'll deal with that in a different time.